Today we're going to talk about rewriting equations and formulas. An equation that has two or more variables is called a literal equation. Basically, things like area equals pi r squared, the area of a circle. You could have the area equals length times width for the area of a rectangle. These are literal equations because there are two or more variables in them. So we're going to talk about how you can rewrite one of these. So basically, to rewrite one of these, we solve for one variable in terms of, and this is going to be a phrase we see a lot of this year, in terms of the others. So to kind of look at the example that I just kind of talked about, when I talk about the first equation that we were looking at, a equals pi r squared, there's two variables there, a's and r's. We know that pi is a number, not a variable. But this one is already solved for a's. We're solving one variable in terms of r's. The second one would be three variables, and it is solved for one variable a in terms of l's and w's. So that's what we mean by what we said. We rewrite it in solving for one in terms of the others. So what does that really mean and how does that look? So for example 1, rewriting an equation. So in this equation we are solving for y's, which means I need to get y by itself. So here's how we're going to do that. So I rewrite my equation, 2y plus 5x equals 6. And again, I'm solving for y. So this is what I need to get by itself. So when I think of SADMAP, it's kind of the same idea. I just got to think about what am I moving, but how I'm moving it is the same. So when I look at plus 5x and times 2, the two things I'm trying to move, I'm going to subtract first. So notice that I'm subtracting, like in SADMAP, before I would look at the division that we're going to do next. So I look at my 5x and my 5x, and those are like terms, so I can subtract, and I'm left with 2y. And on the other side, if I just think about what that says, I'm doing 6 minus 5x. Now remember, we cannot combine those because they are not like terms. 6 minus 5x is all I can do for the moment. But I'm still not solved for y's, because y's are still with the 2's. So my next move is to say now undo times 2, which means to divide by 2. Now here's a mistake that a lot of us make that we have to be careful of. So on the left hand side I'm okay. 2y divided by 2 will leave me with y's because those cancel with the 2's divided by 2 equals 1. On the right hand side, and this is where sometimes we run into mistakes. On the right hand side, when I have two terms that I'm dividing by a number, I have dividing 6 by 2, but I also have dividing 5x by 2. If I have two terms connected with a plus or minus, like we do in this one, see we have a plus or minus dividing the term 6 and 5x. I have to make sure that 6 gets divided by 2 first, and then negative 5x also gets divided by 2. So we got to think of this as two separate divisions. So 6 divided by 2 is 3. And then secondly, negative 5x divided by 2 is negative 5 halves x. Now we're okay leaving the answer like this. This is as far as I can really go. Nothing more that I can really do. The one thing that I would maybe start to have us thinking about, because it's going to be coming up in a few chapters, is trying to rewrite this in a different form to help us with our graphing. So one of the other things that I might want to do is I might want to get that x term in front of 3. So to do that, I got to make sure that I take the sign with it. So notice that it says 3 minus 5 halves x. So I can rewrite the 3 minus 5 halves x by just simply bringing the minus 5 half x in the front, and the 3 in front of the 3 is actually a plus, so I can change it to plus 3. Obviously the mistake we can see very clearly here is that some people are going to just move the numbers and do 5 halves x minus 3. you got to think the sign in front of the term stays with the term, and then I can move them from side to side. Either of these answers is fine. For now, the top answer is perfectly fine. We will be wanting to try to get you to start focusing on the second one because it's one of the forms that we use to graph equations. So on this next one, remember that a formula shows one variable and how it's related to the other variables. Basically, a formula is a literal equation. So the formula for the volume of a pyramid, they give this to us right here. 1/3 length times width times height. Solve for the height h. Really, another way to write this is by saying in terms of L, W, and V's. So when we say solve the formula for h's, what is that going to look like? So 1/3 length times width times height is my formula. Solving for h means everything else has to get away from that. So I can do this in a couple of different ways. I think what I would like to do with this one first is to move that 1/3. I think the 1/3 is potentially an issue with how we handle that. So we see 1/3 times L times W times H. So to move 1/3, I divide by 1/3. Remember, I do it the same thing to both sides. Now, when I take V and divide it by 1/3, remember, V divided by 1/3 becomes V times the reciprocal, which is 3/1. And since V is really V over 1, what it becomes is 3V. On the other side, the 1/3 divided by 1/3 cancels. Now, because this is not connected by addition or subtraction, I only do that division one time. When the previous one we had two different terms of addition and subtraction, we did it to all of them. I only do it the one time this time. So that's going to leave me with L, W, H. I'm still trying to get H by itself. So at this step, I'm going to do two at once. I'm going to divide this by LW. Okay, and what that's going to do is that's going to help me eliminate the LW on the right. Those become 1s, leaving me with H. And on the left, I look at all that and I think, I have nothing to reduce the 3 with. The V has nothing that I can do with. There's really not much else I can do except just kind of rewrite it for now. And basically, lastly, I think we would want to turn this back into H on the left-hand side. And just by flipping it around, I get 3V over LW equals the H. And that's all I can do. And basically, if somebody tells me the volume, the length, and the width, I can plug them in and tell you the height. But for now, that is just rewriting the volume formula of a pyramid. So for this next example, we're going to talk about temperature conversion formula, basically converting from Fahrenheit to Celsius. We can see the formula is C equals 5/9 times the parentheses F minus 32 close parentheses. Basically what we're looking at is we're trying to figure out which one has a bigger temperature, a lightning strike or the sun. So we could actually do this in a couple ways. I could convert the sun temperature to Celsius or the lightning temperature to Fahrenheit so I can compare them. But because the second part of this question that I'm adding basically is asking us to figure out the temperature of lightning in Fahrenheit, we might as well convert the lightning to Fahrenheit and then compare. So basically what I'm going to do is the following. I'm going to come down here and I am going to solve the Celsius conversion formula for F in terms of C. So we can compare. All right, I already know this Celsius to Fahrenheit. I already know that the Fahrenheit for the sun is 11,000. What I need to figure out is what is the lightning, which is given in Celsius, in Fahrenheit. So first what I'm going to do is take my formula. C equals 5/9 Fahrenheit minus 32. And I'm going to convert that to F equals. So we're going to solve for f. So again, we got to think SADMEP here. I'm trying to get to the f, but the f is in parentheses, and parentheses comes last. So the first thing that I have to take care of is the division to move the 5/9, because it says times 5/9. So I'm going to divide both sides by 5/9. Now when we divide c by 5/9, that turns into the reciprocal of 5/9, which is 9/5, times c for the left-hand side. Notice that I flip it over and I multiply. On the right-hand side, 5/9 divided by 5/9 becomes 1, and that now allows us to get into the f minus 32. At this point, I'm now going to move the 32 over with addition, because we're doing the opposites, and I get f equals 9/5 c plus 32. Now again, we don't normally see formulas in that orientation, so I think what we want to do is make one more switch here and bring the f to the other side by itself. We do want the variable first if we can, so 9/5 c plus 32. That is rewriting the formula to now solve for Fahrenheit. So again, we come back up here, the other part of this question was, what is the temperature of lightning in Fahrenheit degrees? So I got to come back down here, and we know that the lightning is 30,000 degrees Celsius. So here's where I just use my formula. Our new formula here is 9/5 times 30,000 plus 32. At this point, because I have all numbers on that side, I just use my regular PEMDAS. 9/5 times 30,000 becomes 54,000 plus 32. So the lightning actually has a temperature of 54,032 degrees Fahrenheit. And then therefore, this is the symbol for therefore, those little 3 dots in a triangle. Lightning has a higher temperature compared to the sun. And we got that by converting Celsius to Fahrenheit and then looking at them in the same common terms. Writing and rewriting these formulas, they are something that we need to get good at so we understand how to manipulate equations. Not something that you're ever going to do in the real life. In the real life, again, with a formula, you're going to plug in what you have and then solve for what you don't have. It's a way of practicing equations that we're familiar with, but we will be doing a lot of manipulating of regular other equations with more than one variable, so it is a good skill for us to practice with.